Okay, dah record So K1, A1, TH sebab material 1 dia temperature panas minus, minus TA over length of this guy lah. Length 1. Okay, length 2. Okay, so this guy now, the rate of heat transfer for this guy, material number 2, is K2A2 TA, because TA is greater than TC. So TA kena dululah, minus TC over L2. The length can be different from L1. The area can also be different than material, but I think for your syllabus, kita akan assume A sama, unless dia cakap tak lah. But most of the time, A akan sama. Okay, L je lah yang selalu berbeza. Okay, L berbeza, K berbeza sebab material lain-lain. Alright. So now let's move on. Habis recap today. We are continuing with conduction with multiple materials. We talked about conduction with multiple materials in series. Oh, sorry, there's another equation, which is when you have two or more materials. Tadi kita cakap pasal 2 in series, Q1 over T1 equals to Q2 over T2. Now we have 3 materials or more. Dalam contoh yang rainbow ni, it's a rainbow, but it's not a rainbow, it's a different type of material. So contohnya ni copper, ni iron, this is aluminum, tak tahulah macam-macam lah. That's why they have different colours. In real life dia tak macam tu in real life nampak sama je. Tapi this is to portray that they are different materials. That's why they give you the rainbow. Okay, please don't be expecting rainbow colors outside. Okay, so this guy K1, this guy is K2, K3, K4, blah, blah, blah. As you can see here, the L are different. The L's are either shorter or longer. It's something that you need to be aware of. Okay, this is L4. Tak kisahlah, korang tahulah K1 lain, K2 lain, L1 lain, L2 lain, so on. And then you just plug it into this equation depending on the material. If K1 is 10 cm, that is what you should put in your L1. Jangan letak semua L sama, because it depends on the length of the material. Okay, so A, assuming that the area is the same, you start with the hot minus the cold. Okay, it's pretty simple. You just need to know which goes with, where goes where. All right, moving on. Okay, so this one is in parallel. Series tadi bersiri, bersentuh. Parallel, dia tak bersentuh dengan each other. For example, this guy is copper, this guy is iron. They don't touch each other. Apa yang sama, apa yang menyamakan diorang? Apa yang menyamakan diorang? Okay, they are touching the same source. So that is what makes them in parallel. Okay, previously it was like this. This was TH, this was TC. I had this material and I had this material. They were touching each other and they were not necessarily touching both sources. Kalau parallel, they are touching both sources. The hot source and the cold source. That is parallel. Okay, they are touching both sources. They are not touching each other. Okay. So this is your equation. QT is equal to Q1 over T1 plus. It's a plus here. Okay, it's not equal, it's a plus. So you know what Q over T is, just plug it in. Know what K1 is, and you have to know what is A, what is L, and so on. Senang je, just have to remember the different types of equation and the situation that goes with it. Okay, so let's take a look at this example. I'm not going to ask you to do this. Kita ada exercise lain nanti. Find the amount of heat that will flow in an hour through an aluminum rod. Okay, find the amount of heat. So it's asking you what is Q. Did it ask you for the rate? Well, it says in an hour. So yes, it's a rate. But your T is equal to, if we are talking about in SI units, your T is 60 minutes times 60 seconds. So this will give you seconds. Okay, so it's asking you what is Q. That will flow in 1 hour or 60 times 60 seconds through an aluminum rod, 8 centimeter diameter. Okay, so always when we have diameter, convert to radius. So the R is 4 centimeter, which is 0.04 meter. Time is 60 times 60, which is 3,600. Good, 3,600 seconds. And if one end of the rod, so this is our rod, we only have one material here, thank God, maintain at a temperature of 130 degrees Celsius. So your TH, this guy is 130 degrees Celsius. And your TC is 35 degrees Celsius. So that is how you start the problem. Okay. Abaikan yang ni. Okay, so this is the source. Thermal conductivity of aluminum is 240 watt per meter per second. So this guy is your K. Okay, so use your equation Q over T, K, just 240. Ka, what is your A? This is a rod. So rod area is this guy, the circle, right? So it's pi r squared. So this guy is pi 0.04 squared, right? KATH, which is 130 degrees Celsius minus 35 degrees Celsius. Do I have to change to Kelvin? No. Why? Because this guy is in per Celsius. So that's your hint. Your constants or coefficient gives you the hint. What units should you use in the equation? So here it says per Celsius. So your temperature should be in Celsius. Don't have to convert it. Okay, so tadi pi r squared. Next, moving on, Ka Tc over T minus Tc, Th minus Tc over L. What is our L? It is 1.5 meter long. Forgot to write that down. 1.5 meter long. Okay, so that is our L. Now, one thing to note here is that your L is in meters, but your diameter was in centimeter, which is why I converted it to meter throws. If you want to use your length in centimeter, I don't encourage it sebab your units kat sini pun dah meter. So nanti nak kena boleh, tapi nanti nak kena convert tu memang akan jadi huru-hara. So just use in SI units. That's the safest way to use this equation. Use in Celsius, use in meter. Okay, so sama tak? Sama. Sabar. Kita nak cari Q. Find the amount of heat that will flow in an hour. It's not asking you the rate. It's asking you what is the Q in an hour. So sebab tu kat sini dia darab dengan 3,600 seconds. Okay, this equation gives you Q over T. It's asking you what is Q. So benda Allah ni darab dengan time. Sebab saya bawa ni ke sini. Okay, I hope that's clear. Whatever that value is, okay, dia kata kat sini 2.75. Malas lah nak kira calculator, but nanti yang ni bawa ke sebelah sana. Okay, so this guy is 3,600 seconds. This is your time. Again, why am I looking for Q? Because it wants to find the heat delivered, the heat that will flow in an hour. If dia tanya what is the rate of heat flow, then yes, I want Q over T. Okay, but now it's asking you for a specific time. Okay, another example that can go with this one is find the heat that will flow in 1 minute. So what happens? You will need to time Q over T with 60 seconds to eliminate the T. Okay, tanya what is the heat in a specific time, you find the Q. Okay, moving on. I hope that was clear. Kalau soalan boleh tanya. Ini soalan apa? Okay, this is the same stuff, but it's a different K. Let's do this exercise later. Let's continue with jangan buat exercise nanti banyak. Okay, let's move on with convection. Okay, so convection, what is it? It's a process of heat transfer by actual motion. Previously, conduction, there was no motion. We only collided with each other. Not we, but the atoms or molecules collided with each other to exchange kinetic energy. For convection, heat transfer occurs by motion of the medium. Maksudnya atoms atau molecules tu bergerak. Previously, it was menari setempat, right? I did it with Sofara and Sophia. But now, we are moving across the room. I'm moving, usually gases or liquids. The molecules of the medium move along the heat. Only liquids and gases can transfer heat by convection because their molecules can move over large distances. Now, imagine if you have a solid, right? You have like your your phone. That's missing your iPhone kan? Oh my God, what am I doing? Okay, so I'm talking about a solid. So solid, imagine if they can transfer heat by convection, and convection requires motion, right? What happens to your phone? It will, the molecules of your the molecules of your phone will move across the room when it is overheat, right? So that's not supposed to happen. So convection can only happen for liquids and gases. So please keep that in mind. Solids can't do convection, If it can, then it will be very scary. So types of convection are dua, natural and forced. So let's talk about that. What is natural and what is forced? Okay, natural convection, the movement of the substance is driven by the differences in density. The movement of the substance is driven by density. Okay, so how is that? So example, boiling water, the hot part of the water expands, right? When we boil the water, this part of the liquid, kat bawah ni, it will expand because it is being heat up, and then it will rise to here. When it rises to the top, the cold water from the top goes down here to be heated. And then when this guy is heated, it goes up, and then the cold water goes down, and it becomes heated up, goes back again. This process is continuous, right? As long as there is a difference in density, it will happen. Okay, and then you're gonna ask me, Doktor, kenapa air ada different density pula? Macam tu kan? Well, the difference in density is rather small, but it is there. Kita boleh bayangkan macam ni lah kot. Okay, when you have a balloon, and wow, this is very beautiful balloon. When you have a balloon and you leave it outside, tapi itu kena lama pula. Okay, let me find mine. I have a balloon and I put it next to a heater. Okay, tak kisahlah korang tak ada heater kan, saya ada heater. So I put it next to a heater. It expands slightly. What happens? How does it expand? It expands because the molecules of gas in the balloon, they absorb heat energy. When it absorbs heat energy, it has more energy and it is able to move about, right? Bila saya minum kopi, saya jadi cergas kan. Sama lah kat sini. The molecules, they absorb heat energy, becomes excited, moves about. This balloon jadi mangsa. So dia jadi lagi besar sikit lah. But it's not quite obvious lah. But there is the expansion. When the balloon expands, there is more space between the molecules. When there is more space between the molecules, the density goes down. Okay. When there is more space between the molecules, the density becomes less. Okay, so you can imagine it like this. I have 8 atoms in this guy. When I have more space, it will look like this. The atoms do not change. The number of atoms do not change, only the spaces between them. When I have more space, the density is lower. Okay, sama kat sini. When I heat it up, there will be more spaces between the water molecules and the density goes down, there is a difference between the hot and the cold. So they exchange places. And this process happens over and over and over and over again. Okay, sampai semua jadi panas and then it boils. Okay. That was a very lengthy explanation, which was unnecessary. Okay, I hope that was clear. And then we are talking about forced convection. This is the movement of substance. It's driven by a mechanical force. Tadi, it was by difference in density. When you give a heat, there's a difference in density, they move. Right, this one, dia move by a mechanical force. Maksudnya dia paksa. Paksa by mechanical force. Mechanical ni maksudnya movement Movement, macam nak cakap? Mechanical force lah. Contohnya, exerted by an external device such as pump or fan. Dua-dua ni bergerak. Okay, so for example, your refrigerator coolant. The way that your refrigerators are cooled is by forced convection. Tak nampak lah pula gambar ni kan. Sekejap. Let's see if we can see it. Kecil sangat. Okay. Let's start now with number 1. So we have the compressor. The compressor, it compresses a substance down here. This is the hot guy. This is the hot air. The hot air goes to the evaporator. When you evaporate something, it becomes cooler, right? So this guy, the hot air, initially, no, it's not an air, it's a coolant. Coolant ni macam liquid. How do I describe this? Coolant is a liquid, sorry, it's not air. The coolant becomes cool, okay, it becomes cool, and then masuk balik dalam, dia akan lalu dekat fridge. This is where your fridge feels, kenapa tebal sangat ni? This is where your fridge feels cold. Okay, this is so hard to explain. Okay, so and then dia masuk balik compressor ni, when dia dah puas sejukkan fridge ni, dia akan masuk balik, waktu ni dia jadi panas dah lah. So this compressor, it knows that the coolant is now hot, dia akan tolak balik ke sini. Kenapa dia tolak ke sini? Supaya dia boleh disejukkan. Okay, and this process happens over and over again. So siapa yang tolak coolant ni? The compressor. The compressor is doing the work. Kalau compressor ni tak ada, there is no movement. So this is the point of forced convection. You have to have a device to force this movement to happen. But for natural convection, we didn't do anything. We didn't put any force. We didn't have to put in a device. We just had to supply the heat, right? Berbeza dengan situasi ni. Kalau compressor ni tak ada, the coolant will not move at all and it won't work. Okay, so that's the difference. Okay, moving on. Do you have to know how forced convection works in a refrigerator? Not really. You just have to know the difference between natural convection and forced convection. By that, I mean the definition would be appropriate lah. Okay. So what's the difference between natural convection and forced convection? So you can explain that one. Okay. Next, radiation. Okay, so radiation, thermal energy radiates through space from the sun. We feel the hotness from the sun even though the sun is in space. Space tak ada udara, which means that there's no molecules to transfer the heat. And there's no solid in between us and the sun, so it's definitely not through conduction. So it's through radiation, which does not require any medium between the hot source and the object being warmed. Okay, let's see this example. Why, when we put our hand next to a fire, that we feel hot? Most of the time, people will say, oh, senang je doctor, this is because of convection, because there is movement of air. Okay, not really, because when you have radiation, when you have a fire, the air, this is the air that is being heated up, right? The air becomes less dense. Where does it go? It goes up. Does it go to your hand? No, it does not go to your hand. Your hand is to the side. So convection, dia punya movement macam ni movement dia up down up down up down. So to say that you are feeling the fire punya warmth because of convection is incorrect, because you are not in the convection flow. You are not, if your hand is here, then yes, you are in the convection flow, but your hand is not there. Your hand is like on the other side of the fire, which means that it is not by convection. This is why we say when we are being heated up by the fire, even though we are like far away, it's by radiation. Okay, adalah sikit-sikit molecules and transfer the heat, but it's not enough. So most of the heat transfer occurs by radiation. It's not by convection. Please keep that in mind, because this is orang, I would say that this is not common knowledge lah. Okay. So now you can tell your parents and your siblings. Okay, radiation is the transfer of heat by electromagnetic waves. Okay, it's not by molecules, it's by electromagnetic waves. It does not require physical contact or medium like convection and conduction. All objects radiate energy continuously in the form of electromagnetic waves due to the thermal vibrations of the atom. Okay, now this gets a little bit complicated lah. So basically, all objects, dia ada thermal radiation, thermal vibration yang kita tak nampak. Okay, and kita tak rasa pun sebenarnya panas. But all objects have this thermal vibration which gives some sort of electromagnetic waves. And then you go like, doctor, electromagnetic wave bukan bahaya ke? No, we have electromagnetic waves all around us. It's not dangerous. Depends. Kalau banyak sangat, then yes. But the ones that we have around us is not dangerous. The rate of radiation by an object depends on its temperature as well as its surface condition. So temperature and surface condition. Okay, so T and surface condition. I don't know what is that. Surface. So the rate of radiation, the word rate means over time. The rate of radiation is given by Stefan's law. Q over T juga. But this guy, what is this? I think this is sigma. Sigma A E T to the 4. This T is in Kelvin. To the 4, to the power of 4. What is E? E is emissivity. E is a constant called emissivity, which depends on your object, on your object's surface. E is emissivity, depends on your object's surface. Okay, it varies from 0 to 1. Temperature is absolute temperature in Kelvin. Okay, this guy is weird. He wants to do in Kelvin. So please remember that. The Stefan Boltzmann constant sigma is 5.67. This will be given. You don't have to memorize, but you need to know what constant this is for. Kalau dia kasih sigma equals to blah blah blah, lepas tu pergi pakai dekat buoyant force ke, memang kena ketuk lah. Okay, so Stefan's law is for radiation. Sigma A E T to the 4. E depends on your object. A is the area. Sigma is a constant. Okay. Surface area. Okay. As an object radiates heat. Okay, so as an object radiates heat, it also absorbs heat from the surrounding. I know this is like a weird concept to grasp, but bear with me. As an object radiates heat, so tadi dia cakap Q over T, right? Q over T, sigma A E T to the 4. And this is the P that it radiates. This is what it is giving. That is the rate of heat that this object is giving to the world, to the environment. But at the same time, it also absorbs heat from the surrounding. Why? When an object is in equilibrium with its surrounding, it radiates and absorbs at the same rate. So its temperature does not change. Okay? Okay, for example, let's talk about my phone again. So I have my phone. The temperature is lebih kurang the environment I'm in, which is 25 degrees Celsius. I have my aircon on. So this guy is 25 degrees Celsius lah. Anggap je lah. Saya tak tahulah temperature betul dia. So this guy is emitting radiation. This guy is emitting radiation. We're using this equation. That can be described by this equation. So it is releasing some energy which is 10 watt. Oh, banyak gila. Contoh aja. So it is releasing radiation by 10 watt. But if this guy continuously releases energy, remember energy yang kita release ni is heat. If my phone continuously releases heat energy, what happens to my phone? It becomes very, very cold. Lama-lama dia akan jadi ice kan, jadi beku kan. So I don't want that to happen. I mean, God says I don't want this to happen. So when an object radiates heat, it also absorbs the same amount of heat. Kalau tak, nanti semua benda dekat dunia ni jadi sejuk. Okay. So bila saya pegang phone saya, oh rasa macam ais. Letak dalam air boleh jadi sejukkan air saya. But that doesn't happen, right? So it means that my phone, when it is releasing energy, it is also absorbing energy. Okay, so in that case, when the temperature does not change, P radiate is equal to P absorb, which is equal to 0. Contoh fire tadi. That fire is releasing energy, lama-lama dia terpadam kan? Which means that the P radiate minus the P absorb is greater. Maksudnya dia release energy lagi banyak daripada yang dia absorb. That's why eventually dia mati. That's why eventually temperature dia sejuk. Okay. So kalau temperature dia constant, means that the P net is equal to 0. Alright. Okay. Penat pula cakap. Okay, so when T, so this is the equation. This is P radiate minus P. Yes, this is the net. This is the keyword here, net. Maksudnya P radiate minus P absorb. Dia bukan Q over T yang tadi ya. It's not the same as this guy. This is Q over T, not the net. It's just radiation. This guy is net, radiation minus absorption. Okay, so this is radiate punya temperature. This is absorb temperature. When T radiate is greater than absorb temperature, it radiates more energy than it absorbs, vice versa. Okay. Okay, so let's talk about emissivity. Emissivity depends on the surface type, right? We have two types of clothes. One is black, one is white. I think we've learned this in high school, at least I did. We learned that black shirts absorb heat better than white shirts. And a shiny surface reflects heat. It's a bad absorber of heat, right? Compared to a rough surface. So emissivity is related to that. So shiny objects with smooth surfaces, low E values, poor radiators, and also poor absorbers. Kenapa nak cakap pasal absorber? Because they are radiating heat as well as absorbing at the same time, right? So this is why your thermal flask is shiny, so that the heat is not easily escaped from the thermal flask. And then dark objects with rough surfaces has high E values, good radiators and absorbers. Okay, so just remember that baju yang hitam tu is high E lah. Baju yang putih tu low E. An ideal absorber is defined. Okay, another term that you need to know is the ideal absorber or the black body. When they use this in questions, what is the heat radiated by a perfect black body? By that example, dia orang tak kasih E. So you already know, okay, black body, E dia always 1. Okay, when they say, so this object is an ideal absorber, what is the heat absorbed? The E is 1. What is the heat radiated? What is the net heat released by this object that is a perfect black body? E is 1. Dia tak kasih E lah. Kalau dia cakap ayat tu je, dia memang takkan kasih E. So you have to know that E is equal to 1. Okay. So here, this is our example. So we have 20 minutes to go. This is our example yang tadi tu, low emissivity. Maksudnya dia susah nak release heat ataupun dia susah nak absorb heat. When we put in our hot coffee, the heat is maintained in the thermal flask. Kita dah maintain 100%. But susahlah heat tu nak escape because of how this guy is built. The space between the walls is evacuated to minimize the conduction and convection. Maksudnya kat sini, it's almost like vacuum, almost, tapi adalah air. It's almost like vacuum to minimize convection and conduction so that less molecules can collide, less molecules can move about, so that heat transfer is minimized. And then silvered surface minimizes radiation. The neck size is reduced. So when our neck is reduced, can anyone tell me why our neck punya thermal flask tu dikecil? Does anyone know? Macam lihat apa ni? Does anyone know why? Why is it smaller? Cuba fikir balik using the equation.
So that the energy transfer is minimized?
Yes, but why?
Because of the surface.
Macam mana?
Because of the surface.
Because of the surface. Surface is E, right? Betul. But saya yang surface tu, we are talking about the silvered surface of the thermal flask. I'm asking you, why should the neck be smaller?
Because of the area.
Yes, because of the area. Betul. Remember, our equation is sigma A, E, T. If our A is smaller, this is our cross-sectional area, right? Then your heat radiation is less. Or yeah, kalau nak cakap pasal radiation lah. Okay. And our other equations for conduction pun ada area juga. So when we have smaller A, our rate of heat is smaller. Okay, good job. Thank you everyone for joining me in that discussion. Okay, so now kita dah habis radiation, which means that next class kita boleh sambung dengan phase. So let's do an example. My favorite part, because I don't have to talk. Let's see. This one dah buat. Yang ni sama. Okay, let's do this one. Okay. I'm going to give you guys 10 minutes to do the first one. First one je. Then I'm going to call someone who is very, very lucky to help me. Okay. 10 minutes. 10:55. Come back. AM. Kalau ada soalan boleh tanya. Oopsie. Sekejap What happened? Okay. Ada orang nak volunteer tak buat? Saya mesti tak ada. Tahu sangat korang ni. Excuse me. Okay. Slash pula. Okay. So we have 5 minutes left. Can I get Jaya to help me with A? Jaya, are you there? Jaya dah masuk alam
Yes,
lain.
doctor.
Yes. Okay. Can you help me with A? Nanti lagi 5
Sure.
minit. Alright.
The formula to use is Ka bracket TH minus TCOL.
Again, Jaya tak dengar.
The formula to use is that Q equals to Ka TH minus TCOL.
Yes. Tapi kat sini ada I'm asking the temperature at the interface. This is the TA. Macam tak equation tu? It's QT over Q over T equals to Q over T.
Oh,
Hmm.
give me a moment.
Apa?
Can you give me a moment, doctor? Let me read
Oh
out
ya,
my
sure.
work.
Lagi 5 minit. Saya bagi tahu siap-siap.
Okay.
And then who is doing B? Can I get is Hikmah not here? Hikmah ada tak? Tak nampak nama dia. Hikmah. Hikmah. Participants. Hikmah, Hikmah. Is Hikmah here? Hikmah, are you there? Hikmah tak ada Hikmah dengan Aidil ada Aidil. Aidil tak ada juga ke? Aidil. 36. Okay, Ideal and Hikmah is not here. Shasha, can you help me with B?
Yes, Doctor.
Okay, B sekejap lagi.
InsyaAllah, Doctor.
Okay. Okay, Jaya, are you done yet?
Yes, doctor.
Okay, let's do it.
So basically, Q1 over T1 equals to Q2 over T2. So we need to find separately Q1 over T1 first, which we use K1 times the area bracket TH minus TA over the length, which is 390 times by
Betul ke? Saya tak dengar sangat awak cakap, Jaya. So you said K times area times TH minus TA, right? Over a length.
yes, doctor.
Okay.
So it is 390
What is 390? Oh, the K. Okay.
the K
90. Okay.
times by 40
40. What's the unit for this guy?
beg your pardon, doctor?
What's the unit for your 40?
Oh, CM,
cm squared. Cm squared.
CM cube, LCM square.
Okay, betul?
Oh, doctor, it is not 40. That is the volume. I'm sorry.
Okay. Okay, so to keep everyone on the same page, Jaya said, hold on, that's not the area, that's the volume, which is 40. Jaya is calculating this
It's
guy,
20.
so it's 20, okay?
Yeah. 20
Sure.
cm square.
But this guy is long. Is it 20? I think it's 4. 10. And Jaya,
Yes, that.
okay.
I
But yang ni long,
that.
so it should be your L, right? It's 4 centimeters squared, okay? Next,
And then since it's 100 degrees Celsius, we
okay.
need to convert it to Kelvin, I think. No?
Need to change it to Kelvin. Okay. So you want to change it to Kelvin. So how do you change it to Kelvin?
Plus by 273.
Plus 273. Okay.
And then TA we can leave it as an unknown because that's what
It
we
is
use.
an unknown.
And then the length is 10 cm.
Okay.
And then TT on the other hand is 110 4 cm square as well.
And okay.
And the TA we can leave it as an unknown. And the TC will be 0 because I think the I spot will equal to 0.
This is also, this is TA minus 0. Okay. Tidak, tak payah jadi Kelvin.
And we got
Dia jadi Kelvin. Okay. Kalau jadi Kelvin, kena tambah di Kelvin. Okay. Okay. So your L
is 10.
and as well. Okay. So this is how your equation looks like lah. And to solve for TA.
Yes.
Okay. So did you, tapi Jaya tak kira lagi eh?
Belum.
Okay, thank you Jaya. Can anyone help out Jaya? Does anyone want to help Jaya? Okay, tolong Jaya kasi dia tahu. So Jaya's equation is correct, but it needs a little bit tweaking. So what needs to be changed here?
The cm square have to be changed into SI unit.
So the cm squared has to be changed to SI unit. What should it be?
Meter space, so it should be. I'm using 0.08, 0.0004.
Yeah, macam ni. Okay, meter squared. Betul ke? 4 over 100 divided by 100, you get 3. Okay, betul. 0.0004. Okay. Okay, so tadi siapa? Nick eh? Was it Nick or was it Nadira? Tak macam suara.
Yen.
Yan. Oh, sorry Yan. Lama tak dengar suara Yan. Okay, thank you Yan. So Yan said it has to be changed to SI unit. Correct. Next, what else should be fixed here?
The temperature.
The temperature, yes, the temperature. Should it be in Kelvin?
Celsius.
Celsius. Okay, Jaya, look here. Your units is in per Celsius. So this guy should be in Celsius. Jaya suka buat kerja susah. Jaya rata lebih rajin. Okay, so it should be in Celsius. So we don't have to convert it to Kelvin. This guy, just let it go. So this guy also has to be in SI. So this is 0.01 meter. Okay, 0.1 meter. Yeah. Okay, so kita convert all the SI units. Our temperature is in Celsius. What else? Are we good to go? Can we calculate it now?
Yes.
Yes, okay. So did everyone get this equation correctly. I mean this unit, all the units. Except Jaya. Jaya salah Celsius. Okay, you should be getting this equation. But to be honest with you, I did not use my calculator yet. Did you guys use your calculator and got the answer?
Yes.
Yes.
Yes. 8 degrees Celsius, eh? All right, that's good. Okay, moving on to Shasha. So Shasha punya kerja dah senang sebab TA dah solve. So Shasha, how should you do B?
Do we use the equation Q over the change of T equals to A bracket T1 minus T2 over bracket L1 over K1 plus L2 over K2? Or is it a different equation?
Lagi sekali Shasha, Q over T equals to?
Equals to A bracket T1 minus T2 over L1 over K1 plus L2 over K2.
Okay, so let's ask our friends. What do you guys think? Should we use this equation? To find out what is the Q? Semua tak tahu. No guesses? No one wants to guess? Takut buat salah takut buat salah. Okay, let's see the answer. Okay, so Shasha tried with that equation. Ni soalan yang tadi, soalan Jaya. Just Q over T equals to Q over T. Okay, this one is Shasha's part. So Q is KA. Basically, this person used TA. Yeah? That's why I said it becomes easy when Jaya already solved for it. Because this guy is TH minus TC. This is your A, this is your K, and this is your L. Why does this work? Because Q over T is K, this is Q1 over T1 is KA TH minus TC over L, which is the same as K2 into TA minus TC over L. Sama je. What I want to know here is what is the Q in 1 minute? So I can use Q2 over T2. I can use Q1 over T1. I can also use the equation that Tasha proposed, is Q over T, apa ni, L, TH minus TC over apa tadi? L1 Q1 plus L2 K2. Boleh. All three will work. It should work. Okay. Kalau korang try and tak dapat, you can let me know. But if I want to use this equation, yes, boleh. Q1 over T1, boleh. Q2 over T2, boleh. Because why? The values are the same. This value should be the same as well. Okay, Q1 over T1 is equal to Q2 over T2 equals to Q over T. So now I just want to know what is the Q. I want Q, so I have to multiply this whole thing. In this case, it is using TH minus TA. This is TA. Okay, so in this case, it's using TA, TH minus TA over L times with time. You nak tahu in minute. When I told you earlier, if they want to know what is the heat in a specific time, you need to find the Q only. So times with 60 seconds. SI units, 60 seconds over here. Ooh, this is not clear. Okay, does that make sense? Whoops. Who is that? You okay?
I'm sorry, I actually unmuted. My chat is trying to bite my earphone.
It's all right. Okay. So faham ke everyone? Kenapa kita boleh pakai macam-macam equation for this soalan? Does it make sense or is it more confusing? Times 60 seconds. So this is your equation that you should use. Okay, TA was given by Jaya already. So you just plug in the rest. Is that okay? Is everyone okay with this? Oh, dah terlebih masa. Okay, I'm sorry, terlebih masa 6 minutes. Hope you guys have a great day. Have a great weekend. If you have more classes, good luck with that one. Don't sleep. Take care. Bye-bye.
Thank you, Doctor.
Okay, doctor.
Doctor.
Thank you,
Doctor.
Doctor.
Bye.
Doctor.
Doctor.